We're still on Chapter 2, Section 2.4, Part 1. Solve using algebra to find a variable, write an equation, solve, and check. So, the sum of the measures of the angles in a triangle is 180 degrees. Two angles have the same measure, and the third angle is 20 degrees less than the sum of the two smaller angles. Find the measure of the three angles. So we're looking for three angles. Two of them are actually the same. So let's just say the first angle, the second angle, and then the third angle. It says two of them have the same measure. So let's let those be the first two. Let's call them x and x. Later we'll put in the degree symbols. And the third one is 20 degrees less than the sum of the two smaller. So that means I have to add the two smaller and then subtract 20. So the third one is really 2x minus 20. So we have three angles, and what do we know about the sum of the measures of the angles in the triangle? That they add up to 180 degrees. So we're going to add the three angles together. Here's the first angle, plus the second angle, plus the third angle is 180 degrees. Notice I'm leaving off the degree symbol because it's easier to solve the equation without using the degrees, but later we will put that in for our answer. Alright, so here's how we defined our variables, and we have an equation, so now we solve it. So we have x plus 2x. So we've got to add those like terms. That's 4x minus 20. And then we'll have to add 20 to both sides to isolate the variable on the left side of the equation. 4x equals 200. And then divide by 4 to finally get x equals 50. So it looks like x is 50. So it looks like the first angle would be 50. So let's write 50 degrees. And this would be the same one. It would be 50 degrees. And let's see. If x was 50 degrees, the first two are 50. It says the third one is 20 less than twice that, or add the 2 and minus 20. So that would be 100 minus 20, or 80 degrees. And does 50, 50, and 80 add up to 180 degrees? Yes, it does. Awesome. So the answer is the angles measure 50 degrees, 50 degrees, and 80 degrees. Okay, and the check, of course, if you need to write that out, you could just write 50, 50, and 80 adds up to 180. And you're also making sure that this third angle really is 20 less than the sum of the first two. 50 plus 50 is 100 minus 20. It really does add up to 80 degrees. So it all makes sense. We're moving on to Section 2.5, Part 1. Substitute the given values into each given formula and solve for the unknown. So the first formula is A equals 1/2 h in parentheses b plus b. This is actually the formula for the area of a trapezoid. What's important to note here is there is a uppercase b and a lowercase b, and those represent different numbers. So when you are doing math, be very careful not to switch between lowercase and uppercase letters. They may represent different things. Alright, so what we need to do is solve for the variable that isn't here, and that's h, because it didn't tell me what h is. I know what a is, I know what the uppercase b, the lowercase b is, so we're going to plug all the numbers in. Instead of a, we're going to write 52, so replacing a with 52. We don't know h, so we'll just write the h 1/2 h. And the large b is 8, the little b is 5. So the first step is to replace the variables with the given values, and then we need to solve for h. All right, at this point, I would simplify the right-hand side first by adding 8 and 5 inside the parentheses. So we have 52 equals 1/2 h times 13. And it does look funny to see that variable in the middle. So really this is 1/2 times 13 is the coefficient. So you have 52 equals, you could just write that as 13 halves h. A little bit easier to deal with writing it that way. Now how do you solve for h when you have 13 halves times h? One way is multiply by the reciprocal. So the reciprocal of 13 halves is 2/13. So if I multiply both sides by 2/13, then the 13s cancel and the 2's cancel over here. And lo and behold, 13 goes into 52 4 times. I remember that because I think of a deck of cards. You've got 13 in each suit and there's 52 cards in a deck. So I know 13 times 4 is 52. So 2 times 4 is h. So 8 equals h. And that's exactly what we're looking for. So the answer is h equals 8. Now to check this, what you could do is plug in 8 for h, 8 for the large b, 5 for the small b, and simplify the right-hand side and see if you would get 52 for the area. Right, the next formula is P equals 2L plus 2W. This is the formula for the perimeter of a rectangle. And what we're given this time is P and L. We're given the perimeter and length, so what we don't know is the width. W would be standing for the width. So the first step is to replace the variables with the given values. So in place of P, we'll write 96. And in place of L, we'll write 26. And we've got plus 2W. And so now we're going to solve this equation. We only have one unknown, the W. So we need to first do the multiplication on the right-hand side since it isn't simplified. So 2 times 26 is 52 plus 2W. Now you want to isolate 2W. So we could subtract 52 from both sides. That gives you 44 equals 2W, and divide by 2. So we get 22 as W. I'm going to turn that around and write it as W equals 22. Looks like that's going to be the answer. Now for this one, let's look at a rectangle and see if that would make sense. See if you believe this. If the length was 26, and we just decided that the width was 22, then this is what the rectangle would look like. And convince yourself that if you add the 4 sides, you would get 96, or go ahead and add it. 22 and 26 and 22 and 26, just add the 4 sides. That's how you get the perimeter of anything. You add the lengths of the sides. So let's see, 8 and 8 is 16 and 96. So actually it checks as well. You can look at the picture. We're going on to 2.5, part 2. Solve each formula for the specified variable. So number 1, C equals 2 pi r, and we're going to solve for r. By the way, this is the formula for the circumference of a circle, where C is the circumference and r is the radius. So if this was just C equals 2r, you would just divide by 2, the coefficient. But instead of 2, it's slightly more complicated. The coefficient is 2 pi. But we do exactly the same thing. You need to isolate r, so you just divide by the coefficient of 2 pi. Sorry, 2 pi. So C over 2 pi is r, and that's the answer. I've just solved for r, c over 2 pi. That's that.